So now we come to panelling the structure, and it's often quite useful in panelling to colour the meshes. Obviously here we've only got some of the meshes for this boat, just keeping the demonstration fairly simple, but if you colour the meshes, then it can help to keep the panels separate. The colours that we use are the colours defined in Rhino as the display colour. Try to avoid yellow, which Rhino uses for the selected colour, and red, which mPanel uses for the old colour. But of course there are a huge number of colours available. If we'll set the mPanel settings on the new object colour to be preserve colour, then the panels will have the same colour over the meshes, and this can help quite a lot with organising where the panels belong. We're going to panel these to where each mesh makes a single panel. We'll panel this one, and this one, and this one, and this one. I'll delete the old. And slipping now into top view, we can see where the panels belong on the original structure, and perhaps we can move them into slightly more helpful positions. During that paneling process, we would have kept an eye down in the text window here on the shear strain reported for each panel. The amount of shear strain that a particular panel can accept the amount of shear strain which the panel is forced to go under to change into its 3D shape, and the actual amount of shear strain that you can have, of course, depends on the fabric and on the tolerance for small wrinkles. Certainly once we get up to figures as high as 5%, we start to question whether the piece should be made in more panels. A very common thing then is to either deliberately shrink or deliberately expand these panels by a certain amount. We call that compensation or shrink settings. So with a shrink setting of 1% and 1%, the panels would all be shrunk 1% and would then fit really tightly over the frame. If this is a boat cover that's going to be removed and put back on, you may well want to use negative values for these, like perhaps -0.1 or -0.5 and -0.5 to obtain a cover which is just big enough to fit over the frame nicely and without being too horribly sloppy. Those of course can be applied to all of the panels at one time. So now we have our new panels, which are all a little bit bigger than the old ones. We can delete the old. And then we come to adding a seam allowance, and depending on your production methods, you would often want on the seam allowances different widths on different sides of the panels. Often when panels are joined together, you want match marks. Now it is possible to put in match marks at specific points along the edge, but in general it's not necessary to do that. All that we have to do is specify that we want a certain number of marks along each edge of the panel, and as long as one complete panel joins onto another complete panel, then when we add in the seam allowance, delete the old, we'll find that on these edges we have a mark just there which will line up with a mark just here, a mark just there which will line up with a mark just here, and very importantly a mark at the beginning which will line up with a mark at the beginning there, which gives you a good starting point on your sewing. Now I'm just going to undo those seamed panels, because there are a couple of other things that I want to show you. in the situation where you have two panels, like this one here, oops, I've got the wrong panels, like this one here and this one here, that join onto a single panel, this larger panel one here, you would very typically want a match mark to appear at the point where the seam between these two panels joins together. Now on this panel it happens to be absolutely obvious, it's at the corner, but in a more typical situation this may have just been a smooth curve, and what we want is we want a match mark putting in just here where the two panels join. And we handle this in a slightly strange way. We first of all say that one of the panels is a master panel, and we indicate that it's a master panel by colouring it green. We then run a tool, we select the master panel and the panels that they're going to join onto, and we run a tool which is in the utility settings under modify panels. Now on earlier versions of mPanel Production this tool was on the seam page. We've moved it for some consistency. The tool we're going to do is to add mark to adjacent panels, and first of all I'm going to specify a maximum spacing of 0, which basically means that we want no extra marks, we just want the one mark where the two panels join. I can click on modify panels, and just here on this panel, I'll delete the old, you can see an orange cross. An orange cross is a mark which is going to become, during the seaming, an alignment mark. Let me undo that for a moment. It may be that as well as that alignment mark you wanted some other alignment marks up and down these panels, maybe alignment marks spaced about 12 inches apart. For that we would just select these panels, modify them, delete the old, and now you can see you have an alignment mark at the point where the seams join, and alignment marks that will join up with these other panel alignment marks all the way along here. When you go to do your seam allowance, you can of course also specify an additional set of marks for those edges, but it's probably easier for us to see what's happening if we just say that we want no sort of standard marks, and that all we want are the marks which are generated from these orange alignment marks. And so if I go ahead and seam those, delete the old, we'll find that each of those marks has been transferred into a little line drawn in the seam, just as expected. Now I want to cover one other way of adding alignment marks onto panels. You can imagine of course that the ability to specify a number of alignment marks down the side, plus the ability to specify additional alignment marks between adjacent panels, means that most times that's all that you're going to need. But there may be some situations where you want to specify an alignment mark for some special reason along the edge of a panel, and we do that in the 3D model by adding a point. And the best way to add a point onto an edge is to set the O snap to near, and then I should be able to put a point just there, and I'll put another point in just here, just to where we have a couple as an example. When we panel this, if we want these alignment marks on the edges, we also have to select the two alignment marks. And then, when we panel, we have a choice of using points as panel detail. Panel detail are things which are going to be drawn on the inside of the panel to represent positions of zippers, cutouts for windows, all kinds of things like that. Or we can use the points as panel marks. There is actually a more advanced way of using some of the marks for one thing and some for another, but let's try and keep it fairly simple. We'll specify that these points are going to be used as panel marks. We'll go ahead and panel that, and let's just move that panel over here to look at, and we can see that those marks have transferred across into the panel edge. When that panel is then panelled, and again here to make it clear what's happening, I'll specify 0 marks on the side. The mark is translated into a line which is going to be drawn in the scene. Of course, when we panel this mesh here, we would also pick up those same 2 points and would then continue to make a panel with those same marks inside them. So just in summary, in most cases we don't need to add points to establish mark points across from one panel to another, because the program can do that automatically during the panel handling by specifying the number of marks. For joining 2 adjacent panels, we have a procedure which puts marks in the places on the adjacent panels where a panel join occurs. And for those rare occasions where we do actually need additional marks, we can draw them in as points.